Hello, good people. Welcome to video 2. And in this video, we'll officially, I guess, define what the extreme value theorem is. The extreme value theorem, like its cousins, the mean value theorem and the intermediate value theorem, all guarantee us the existence of something. And in this case, we need two conditions. We need f, the function that we're talking about, to be continuous, and it has to be continuous on the closed interval. So if I don't have continuity on the closed interval, continuity has to exist not only in between the endpoints, but at the endpoints themselves. If I have that, then I'm guaranteed something. And here's what we're guaranteed. The function has to have both an absolute minimum and an absolute maximum within in that interval. It could be at the endpoints, it could be in the middle, but somewhere in the interval, the closed interval, there has to be an absolute minimum and an absolute maximum. So remember, every theorem has conditions. Let me do that in blue because our conditions I wrote in blue here. And we should remember that if the conditions are not met, then the theorem can't be applied. Now, that doesn't mean that there is no absolute minimum or absolute maximum if the conditions are met. It's just that we're not guaranteed it, right? So for this particular theorem, the extreme value theorem, we have to have continuity, and we have to have continuity. We have to have a closed interval. If we have those things, then we are going to have, if the conditions are met, then what are we going to be guaranteed? We're going to be guaranteed an absolute max value and I should put the and in capital letters, and an absolute minimum on the interval. And again, the interval could mean in between the endpoints or at the endpoints. This is what we call an existence theorem. I call it an existential, but an existence theorem. And it's related to the other two theorems that we've studied, one of which we just did earlier, the mean value theorem, and then the one we did in Unit 1, the intermediate value theorem. So it doesn't give us the theorem doesn't tell us how we're going to find the values. It just tells us that these values exist. And so for that, we're going to have to establish our own process of figuring out how to find the absolute max and min. But the EVT, the extreme value theorem, is going to guarantee us that those values do exist. Once we know they do exist, then we can start the process. Okay? So here's our candidate's test for absolute or global extrema. And it's going to start the way we find relative extrema, which is find the critical values. Okay? So we're going to find the critical values, meaning we need to find the x values where the derivative is equal to 0 or it's undefined. And then we're going to include the critical values as well as the endpoints in a table. And we're going to evaluate the output or the function value. We're going to plug in those x values, the critical values, and the x values of the endpoint. We're going to plug it into the function equation, the original function equation, not the derivative, the original function equation. Because then we'll be able to tell which value is the greatest, and the greatest absolute value is going to get the title of absolute max, and the least value is going to get the title of absolute min. And so once we do that, then we can use this statement as a way to identify that the absolute maximum is whatever the function value is at a particular x value. So on the exam, you're going to see this asked in different ways. These are different ways we could ask to find the absolute extrema. What is the absolute maximum of f of x? That could be pretty obvious of what we're looking for. What is the global maximum of f of x? Find the maximum value of f of x. What is the maximum of f of x? You're going to see this phrasing, and when you do, you know that we can check the EVT to figure out if the absolute extrema do exist, and then this table is going to provide the process by which to find those global extrema. So in the next video, we'll do some examples in graphs, and then in the subsequent video, we'll do some examples in equations.